So in this particular case, a squared plus b squared equals c squared. However, if I have something like 3 and 4 and 5, that makes a Pythagorean triple, because that is a set of 3 sides that makes a Pythagorean theorem true. So we have 9 squared plus 16 squared equals 25 squared, and that works out really, really nicely. But that's only if it is equal. What happens if a squared plus b squared is less than c squared? So for example, I have 5, comma 6, comma 10. In this particular case, I have 5 squared plus 6 squared is question mark equal to, I don't know, 10 squared. So that's 25 plus 36 is definitely less than 100. So if the two sides put together are less than the hypotenuse squared, well, what kind of triangle is it? Well, if I were to draw this out, I have something about 5, I have something a little longer about 6, and something way longer, which is 10. Well, clearly in this case, we're going to be looking at an obtuse triangle. So using this, we can see that if the legs are leg squared plus leg squared is less than hypotenuse squared, that is going to give us obtuse for the triangle. Versus if they're equal, it would be right. On the other hand, let's go the other way. What if a squared plus b squared is bigger than c squared? So in this case, let's go with a 5 and a 6 and a 7. In this case, I have 5 squared plus 6 squared equals 7 squared, question mark. And let's find out. So 25 plus 36, does that equal 49? No, not at all. That's going to be 61 is definitely greater than 49. And if I were to draw this guy out, I'd have a side of 5, a little longer side of 6. And while this side is still the longest at 7, it's not way longer like the 10 was. So this is going to be acute. So it's an acute triangle. Now, these are not meant to be equal. These are all different sizes. And in fact, this is a really good point to note, is that if I have A, B, and C over here, or actually let's go R, S, and T, what we can say is, what's the biggest side? Well, the biggest side would be side S. And the biggest angle would also be angle S, because it's across from the largest side. So then the smallest, so if I had side T, would be the smallest because it is across from angle T, and that's going to be the smallest angle. So biggest side across from biggest angle, smallest side across from smallest angle, and vice versa. But in all cases, because the two sets of legs squared is less than the hypotenuse squared, we have an acute triangle. So right would be equal, obtuse would be if the legs are smaller than the hypotenuse squared, and acute if the legs were larger than the hypotenuse squared. Now this becomes important because the Pythagorean theorem only works for right triangles. If you don't have right triangles, then the Pythagorean theorem won't work. Turn it around. The converse says if the Pythagorean theorem doesn't work, it can't be a right triangle. But what it also allows us to say is it an obtuse triangle? Is it an acute triangle? Those are things we can look at, keeping in mind that we have other inequalities like biggest side across from biggest angle, smallest side across from smallest angle. Okay,